Hello, calculus students, and welcome to another online lesson. Today we will be dealing with vector equations once again, and today we're going to try to find the intersection between two lines expressed as vector equations. Our long-term goal is to be able to use these to solve IB level problems. No terms of notation today. We're just building off of what we've done on previous lessons. Again, we have our vector equation. In fact, in this case, we have two of them. We have our position vector, or our starting point, as well as our velocity vector or directional vector. We have a second equation with a different initial point and a different directional or velocity vector. We have scalars s and t, s from the first one and t from the second one. And we want to find out when these intersect. Well, when two lines intersect, they end up crossing at a single point. So if I have a line here to represent one equation, and I have another line here, they end up intersecting at a single point. Vector equations are useful to find specific points on the line. In this particular case, since they are going to meet at point E, we know that point E is on both lines. So there is an x and a y value, which is E on line 1, and there is an x and a y value, which is that same point, which is on line 2, which means that these x's that I just circled in red, as well as the y's, are equal to each other at one point. So what we're going to do is we're going to break up our two equations into their parameters. For line 1, I have the following parameters. I have x equals -2 plus s times 3, or 3s. And then I also have a y is equal to, and then the 1 with the 2s. For line 2, we also have parametric equations, and that's going to be x equals 15 minus 4t, and y equals 5 plus t. Again, we know there's some point that exists where this x value will be the same as that x value. So let's go ahead and set these equal to each other. So we have -2 plus 3s, which again was my x parameter from the first equation, from the first line. I'm going to set that equal to this x parameter over here, which is 15 minus 4t. I will do the same thing with my y's. Write that in black, and so this y should be equal to that y. And following the same pattern, I take 1 plus 2s equals 5 plus t. Notice we have two equations. We also have two different variables, so this is a classic case of a system of equations. We have lots of good ways we can solve this. Elimination is always a favorite. We can do substitution. For example, the t over here on the end is almost by itself if I got rid of the 5, and then I could substitute with that. But I am partial to elimination, so I'm going to use that method. And I need something to cancel out either the s's or the t's. I could make these s's like one equation into a +6 and one into a -6 by multiplying by 2 and -3 respectively. But instead, I am just going to multiply this bottom one by a -4, scalar of -4, I'm sorry, +4, which will make this -4 right here cancel out when I add them together. So when I do that scalar multiplication, I will have 4 plus 8s equals 20 plus 4t. Again, that was just distributing this 4 to each and every one of those terms. I'll rewrite my red equation right above it, which was -2 plus 3s equals 15 minus 4t. And now I just get to add them together. The -2 and the 4 become 2. 8s and 3s becomes 11s. 15 and 20 becomes 35. And the -4t and the +4t cancel out, which is exactly what I wanted to have happen. Now to solve this problem, I am going to subtract 2 from both sides to get my variable alone. And I'm I'm running out of room here, so we will move up around here, and I will end up with 11s equals 33. Again, 35 minus the 2 gives me the 33 over there. My variable is almost alone. Divide by 11, and s equals 3. Now, I didn't actually ask me to find s and t. I've found s, but the question says find the coordinates of e. Once you have s, you could go back and plug it into either of these original equations here or our modified equation over here and plug in the s and then solve for t. But I don't actually need to do that because I know that this x and y over here is the same as this x and y over there at the point E. They have intersected the two lines. And I'm just trying to find the coordinates of E. And you'll notice one of my equations, which is line 1, only requires me to use s's in my equation. So I'm going to plug in the s value of 3. So to get the x value, it'll be equal to -2 plus 3. And then again, I'm using this s right here, which has a value of 3. And so I get x is equal to 9 minus 2, which is 7. And now I can do the same thing for the y. Y is equal to, and I'm now using this equation here with the s, 1 plus 2 times the s, which is still 3. So 1 plus 6, which also gives me 7. So my final ordered pair is 7, 7, and that would be point E. All right. If you wanted to double check your work, you could also go back, find t, and then plug t into line 2 and make sure that you also get 7, 7 there. Or you can plug this 0.77 in and solve for each of these t's after plugging in the 7, 7 for the x and the y, and you should get the same value for both of those t's. All right. In the book, we have page 336, which is all about finding intersection between vector equations, finding points of intersection. And then 332 expands on what we looked at a little bit last class, involving shortest distance between vectors and points. So a little bit of a challenge there for you. Until next time.